one of the real benefits or takeaways out of this project is it was really an SSR 1 project.
Welcome to SSR On Air. I'm Mike Rogers, your host for this monthly podcast brought to you by Smith Seckman Reed. Tune in as I interview leaders, colleagues, and clients about what is going on internally at SSR and in the larger engineering community. So just introduce yourselves a little bit, maybe. I think it'd be good to talk about what your current position is, what you do for the company, and then we'll tee up a little conversation.
You want me to start?
Yeah, go ahead.
Start. I'm Chris Loftis, Department Discipline Resource Manager. I've been in that role for about a year and a half now. Before that, really kind of mechanical engineer, project manager for the sports group within SSR. I've been here for about 11 years now. So
Okay.
I'm really kind of in my current role in charge of managing a team of folks to make sure the work gets done and make sure we have the right resources to staff the projects properly.
Okay. Tennessee Tech grad.
Tennessee Tech grad.
Okay.
Yep.
All right. Greg?
And I'm Greg Isaacs. I manage SSR's building enclosure service line, building envelope, basically exterior systems, roof, walls, windows, doors, anything that can leak water or air. And we differentiate from architecture in that we're kind of specialty consultants in those systems. And we can talk about that more, but really providing that kind of specialty engineering, verifying those systems are working. And we've got a team of consultants across the country in 6 locations now, and doing all sorts of exterior consulting, from assessments to commissioning, testing, and design and repair work as well.
Okay. Very good. So some, you say design and repair work. So how deep does that go? What do you guys do on that? Just to touch that a little bit.
Sure, that's mostly limited to repair work, right? So if we assess somebody's roof system and recommend a repair, then we have roof consultants that can help drive that kind of specialty repair to the finish line.
Any forensics type work in that?
Yes, yeah, a lot of it.
It's all forensics type stuff.
Yeah, I mean the assessment being more of a just general understanding of what's at the property, but then sometimes there's water leaks or damage or other issues that we're kind of specifically investigating. Maybe you need a special test for it, or procedure that it's not just tell me everything we have, it's hey, stop this condensation or water leak or whatever the issue may be.
Yeah, okay. So it's a pretty unique approach to things. I mean, for our industry, when we talk about the things that we do in general, a lot of people don't understand what's going on with the building enclosure, building envelope stuff. So I think it's a good thing to dig a little deeper and open that up a little bit.
Yeah, a lot of unique problems, similar concepts across issues, but unique problems and circumstances that we help teams and owners work out of.
Yeah, it's kind of like I always tell everybody is that every building we build is really a prototype, right? Build it one time. Now the systems and wall structures and things like that, they repeat in some ways, but they're all a little bit different. So you end up with a different connection point or a different something that's never been done before in that particular configuration. So that's part of it. I think that's tough for people to understand that you've never built one of these before. It is a prototype, every single time, just about. So.
Yeah, and I would suggest even more so on the envelope side, right? Any city that you're driving through's got, each building's unique in a different assembly and combination of exterior systems coming together to perform.
Yeah, good deal. So change the subject a little bit. So we're here to talk a little bit about the F&M Bank Arena, which is a project that's near and dear to your heart, Chris. And so maybe tell us a little bit about the project to start out, when it started, kind of what it, how the genesis of it a little bit, and your role in that.
No, absolutely. So, I mean, we really started getting involved with the city or county of Montgomery County, Clarksville, Tennessee, in 2017. And kind of started conversations then, really started kind of digging into the design in 2019-ish is where we really got fully engulfed. And then, as we all know, COVID hit. And we were on the front end of COVID, so we were actually able to get it procured. A lot of the early equipment was already purchased before all the escalation really hit our industry. Thankfully, that got us ahead of the curve. But it's just now opening in 2023. So it kind of even so, we went through multiple iterations of value engineering throughout the design to try to make sure we maintained the budget that the county wanted to spend.
Yeah.
At the end of the day, the county was paying for it with a partnership with Austin Peay, which is their local college, and then Sabretooth Entertainment, which was really kind of a spawn of the Nashville Predators. What they currently have that operate the Bridgestone Arena have taken over, and they're now operating the facility for them.
Okay.
And so as a part of that, there's a lot of entities that had voice into the conversation, and so there was a lot of detail that went into how is this going to involve Austin Peay, how is this going to involve the Predators, and how are the different types of areas within the building, which we'll get into more a little bit later, how do they all tie together, or how do they make sure that they can stay separate for different events? For example, the fire alarm not going off in the practice ice when there's a concert going on, and how are they able to differentiate those really three buildings all within one structure, if you call it. So my role in that was really project manager here at SSR. Throughout the whole process, had a great team behind me, really kind of saw it all the way through. We haven't officially opened yet. I think the grand opening is in June, from what I understood. But they've had a soft opening, and the Preds are now in and operating the building. And they've had, like, Kane Brown came for a week and did practice, so rigging, basically rigging up and down, much like they do with the practice area they have currently at the rehearsal hall down at Bridgestone. So they're renting this out just like anything else, without fans ever being in the building. So they're using it basically every day, similar to how they're doing Bridgestone.
So a lot of people don't know that, but Bridgestone Arena has an entire separate section of it that is for practicing, and so big shows will come in, they'll rig up their shows. It's not just practicing the music, it's practicing the rigging and the staging and things, and it's a whole separate section that most people never even see.
Yeah, I thought that one funny story out of all of that was Morgan Wallen had a free concert at Bridgestone a few weeks back in Nashville. It was the same week that Kane Brown moved into Clarksville. So the rumor was that Kane Brown was going to do a free concert at F&M Bank for all the locals up there, and come to find out he was just there practicing. It was like a big, huge story kind of in the Clarksville town.
Oh yeah, small town.
Very much so. Very much. But
yeah, it's a good town there. I mean, it's a military town in a lot of ways, because you get Fort Campbell there.
Yeah, and there's a huge partnership with Fort Campbell as well, and a lot of the project team got to tour multiple times through Fort Campbell, which was my first time. It was really cool to get to see the behind the scenes of Fort Campbell, which is right here close to us.
You see some of that 101st Airborne training area?
Yeah, and like their dunk tank. That was really cool.
The repelling wall, the big repelling wall. And they have a parachute tower there too.
Yeah.
They do the parachutes.
Yeah, it was really cool.
Yeah. It's good stuff. All right, so as the project's progressing now, who were the architects on it?
So architect was Convergence Design, which is out of Kansas City, sports architect, and then you had Rufus Johnson and Associates, which were the local guys up there in Clarksville. Those two really kind of came together. We paired with Walter P. Moore, structural engineer on the project. There's a lot of stuff we probably can get into structurally about that building that's crazy. I mean, there's a 75-foot elevation change from one side of the building to the other. It may be the first building that I'm aware of that you really can enter on a vent level on one side of the building and at the trusses on the other side, so basically catwalk level. And so it's really unique. You walk in and you're actually coming down to get into the suites on one level. And so underneath this building there's what we call the moat, which is really a separation of the building from the walls that hold up the road around it. And it's about a 3 to 5 foot gap that you could pretty much walk in and it feels like a cave. It's really unique, and you'll look up and 75 foot above you is where everyone else walks.
Yeah.
And it's just huge. And so there's a lot of infrastructure that went in behind the scenes that people will never know about, in order to kind of situate it on the site where it sits. But with that, and really kind of the reason we were talking today, is there was a lot of unique situations on this project, talking about the prototype, the one-off that you don't see a lot of other places. And so we really kind of strategized as a design team on how do we bring in the right resources to this project to make sure that we see it to completion and we don't have issues down the road. One of them being kind of what we talked about with it being 3 buildings in one. So you have the main arena, which is about 6,000 seats, and that's kind of your bread and butter to the building of how it started. But in addition to that, you have a practice ice or community sheet of ice that sits over to the side, situated off to itself. It'll be open 24/7, much like the rest of the Preds Ford Ice centers, right? They have Bellevue and Antioch Ford Ice. They now have Clarksville's Ford Ice, if you want to call it that. And then in addition to that, those two, which are both very cool environments, conditioned for ice quality. And then you have a basketball area, which is locker rooms on the first floor, a practice facility on the second floor, so full court practice facility, and then you have office space on the third floor. And all of those kind of intertwine and connect together, which is what really drove us to want to look at getting Greg and his team involved to make sure that when we're trying to maintain one at a very cool temperature, very dry, while another one's at 72 and 50% relative humidity, that we don't have moisture transfer inside of an interior wall, which was kind of a unique situation. You don't see a lot. I think we see it more in sports than people actually acknowledge sometimes, and we have conversations, but it was a really easy conversation with the architect to just kind of say, hey, we have an expert and in-house that can help kind of look at this and evaluate and see if we need to do a vapor barrier in a different location than what we would typically do, if we need to add something else to the wall section. And so we've got Greg and his team involved to kind of see that one through for us.
Yeah, and that is unique, and I think a lot of our architectural clients don't really think about those things and until we get into it, right? And so it does pop up quite a bit in the sports world. I mean, we've had other projects that this has come up on too, where it's been basketball, ice, pool, all in the same building, and so you've got these barriers that we have to deal with. So how did you guys get together and get involved, and what was the first kind of meeting about?
Greg, I'll let you take it a little bit, but I really kind of just set up the stage with the architect, said, hey, let me bring in Greg and his team to have a conversation about what they can provide us, dig in a little bit deeper on what that looked like, and then you guys kind of took it from there and ran with it. But
yeah, one of the services that our group offers is vapor drive analysis, and basically we have a couple guys, Brian Marsh and Chris Maurice specifically, are trained up on a program called WFI. This is abbreviation WFI, and basically that's a platform developed by Oak Ridge National Lab, and it models vapor drive across a wall assembly, and it helps tell you what your risk of trapping moisture and creating mold in the wall is. Basically, you want, walls are going to get wet, they're going to get dry, they're going to get hot, they're going to get cold. Is that a problem, right? What's our risk? And it's a tool. It's not the only tool, but it's a tool to help us understand how that wall system or roof system is going to work over time, right? It's not a static approach like the kind of glazer method we used to do 10, 20 years ago. It's more looking at dynamic systems and different weather patterns, unique to that project location. You're building the project-specific wall or roof assembly with manufacturer-specific materials, and you're orienting it in the right direction. And basically, just another kind of tool in the tool bag to evaluate risk of trapping moisture in a wall. And we've done that on projects all over the country, in all climate zones in the U.S. It certainly can be important in Tennessee with our hot, humid air. But then also gets more interesting when you have unique spaces inside. You mentioned pools. Obviously, we have an ice rink here, and there's just a higher level of concern on the project that, hey, we've got this unique thing with ice year round, and Tennessee gets hot and humid in the summer, obviously. So let's just look at that and make sure we understand how that wall is going to perform, or we evaluate, are we checking risk correctly with that. So I think I started this by saying we work on the exterior of the building, but cases like this, we're also looking at interior walls, which is fun and interesting when you have an interior space that's got such a unique temperature and relative humidity that you start to consider the envelope of that space, the envelope of that room, and that might have outside walls, it might have inside walls. So we did a lot of models for that. We were checking the roof and wall of the typical outside walls, specifically on the area with the ice rink in it. But then also did the same thing at some of the interior walls and said, hey, it's going to be cool and dry in this room, and then maybe it's hot and humid in this space next to it. Is that a problem? So our guys were able to build those assemblies in the system and run the model, and we didn't identify any concerns, and shared the results with the architect and talked about them and said, hey, here's what the model's showing us. We're not seeing any big items of concern based on the assemblies that they had. So it helped provide a little bit of confidence that, hey, we've got this really cold thing in a hot environment, but we've got a little level of comfort now that these wall systems inside and out are gonna work the way we want them to.
Yeah, build up that confidence in the way it's being put together. It's interesting. I mean, just not to get too technical, because I know you're trying not to get too technical on it too. But
sure.
Just so people that are listening understand that the vapor is always going to move from the higher humidity point to the lower humidity point, and inside a hockey rink, it's a very low humidity.
Right.
I mean, the intent there is to keep it low humidity so that you don't get fog on the ice and the softening of the ice even, right? If you get a lot of condensation on the ice, it becomes a soft ice, and the hockey players don't like soft ice, right? And there's a lot of that that goes on. So it's about mitigating that as well, right? You don't want the moisture moving through the wall and continuing on as much as you can, but then you don't want it to take a stop midway through the wall and fall out somewhere. And that's really what your Wolfe analysis is looking at, trying to determine that for us.
Yeah, that's right. It's going back to your thermo classes, hot to cold, wet to dry, and saying, hey, is it getting stopped? Is it working the way it needs to? Do we need a vapor barrier? If we do, where should it be? Where should the air barrier be? Where should the insulation be? Should it be in the wall, outside the wall? So there's a lot of variables there, and glad this one kind of worked through the first time. Sometimes it doesn't. Sometimes you got to adjust something and try a different material, or tweak where you're putting the insulation, maybe move it towards the outside, or adjust the permeance of your air or vapor barrier. We didn't have to get into that here, but those are all variables that the program allows you to input and understand, and include in it.
Yeah, sounds like the convergence guys did a good job on the wall design, right?
They did.
Yeah, that's good. So at what point did you get involved? I mean, where were you in the project when you said, hey, maybe we ought to get a little
that's kind of where it's interesting, and I forgot to kind of glossed over that, but one of the real benefits or takeaways out of this project is it was really an SSR 1 project, in the fact of we had the MEP team, we had technology that was on board starting design. In addition to that, we brought on commissioning through the services, so we had normal commissioning, both mechanical and electrical. But then as a part of that, we also brought you guys on to do building enclosures commissioning and roof assessment as well, correct?
Yeah, we had some roof consulting in there. We did a lot of different things on this one. So the vapor drive is more of kind of a design assist tool, I'll call it, assist the design team in evaluating their system. And commissioning got into more of the kind of third-party consulting, a little more process driven on kind of the basic tasks, but that having some QA things all through both design and construction and into occupancy. But then we also ended up performing water testing on some windows, and then also brought some roof consultants out there. Mike Spock is one of our roof consultants at SSR, did some RRO work, and basically we can get into that, but that's basically where he stands on the roof all day, and roof is a really critical system, right? It sees all the weather, sees all the rain immediately. It's one of the first lines of defense. So having that service of a highly experienced 30-year guy knowing roofing on the roof during a couple days on site just to verify quality goes a long way. When you're the installer and you're the one in the 70-degree heat or 90-degree heat putting these things down, sometimes you might miss something here or there, and it's helpful to have an experienced guy just there helping guiding and working with the builder to make sure we're setting the standard of care for how things go down. So yeah, I did a little bit of the design assist part, and then kind of the commissioning process, which included testing, included some roof consulting. But yeah, I think to go back to your first question, approximately in DD phase is when we usually start to get engaged for the vapor drive. And we usually run those either late DD or early CD. The exterior details might not be fully developed at the end of DD, but we want to be on board and ready to go if as soon as that level of detail is provided, usually in early CD, so we can put that into the model, right? The model's only as good as what we put into it, so we want to kind of be there ready for when that team gets the detail we can put in. And then you can, like I said before, put in project specific components and pick a manufacturer, and they've got their systems in uploaded in that program that you can identify. So there's kind of that sweet spot there where, hey, getting in DDs, which also helps in commissioning, but then also that's a good time to be planning for what we need to evaluate the systems with vapor drive.
And all the services from a commissioning standpoint were direct to the owner. They weren't tied to us either. So it was the design team. We suggested or recommended a one-stop shop from an SSR standpoint, but ultimately they were contracted directly with the owner outside of kind of my purview, so I could kind of keep and maintain MEP and technology driving forward while they were working with the owner on what their needs were. And so it kind of segregated that a little bit, which I honestly enjoyed, because I kind of could keep up to date on the meetings and kind of understand where CX is at and where the plan is and all of that. But then I was just able to call Greg and say, hey, you're already on board to do the normal building enclosure commissioning. Now our architect team is talking about this issue we have internally. Is there a way you could help us with that? And that's kind of where that came from and steered towards, and it was all right at the start of CDs basically, but it was a great conversation, easy to just blend it right in, and it just felt natural to the entire team. So
providing a solution there, and it was, the timing of it was good, right? Because once you pass that point, it starts to cost money.
Absolutely.
To make those changes, so it was good timing for it all. So
Right.
Good.
Yeah, and I think one good differentiator in envelope commissioning is we have the similar parallel process to mechanical, electrical, but there is also another component just based on the systems themselves, in that a lot of our reviews are a little less rigid than some kind of formal processes, more just kind of quality driven. So we've got some space in there to be a consultant to the team and work. We are, like you said, direct to the owner, but we are a resource to the architect, and we had a lot of phone calls and discussions on certain details and specific things where we could work together, and they just would call up and have a question. We'd share some notes and kind of some examples of things that have worked before or haven't. And that was all really part of what we think needs to be part of the commissioning process, is to not just execute that process, but also just be a resource to the team on these frankly complex exterior systems.
Yeah, I guess the beauty of that, Greg, for you is that you've got a lot of clients here, right? You've got the owner of the building is obviously a client, the architect's a client, Chris's team's a client. They're all clients to you because the things that you're doing are benefiting all three of those groups along the way. Protecting us from things that could go bad from a mechanical standpoint. You lose control of the environment, those kinds of things. Protecting the architect from having a wall system that doesn't hold up, and then obviously protecting the owner from all of those things added together, right?
Yeah.
Yeah. So.
And we didn't on this project, but we also work for contractors, right? So we work for any and everyone that needs just some assistance specific to that project.
Yeah. So with that, and the reason I mention that is because from an MEP standpoint, when we're working on a project, these guys need to remember that you guys can provide a service internally that can give us a view of things that we may not have and keep us out of the ditch or away from things that are going to cause problems. And so it doesn't have to just be a cell outside; it could be a cell inside as well. I mean, and I can see the benefit of that. I mean, it's kind of interesting as we started that, back when we were doing energy modeling, and we tried to do the energy modeling on the teams and within the MEP group. And when you do something part time, you're just not as good at it, right? And now we got a separate group, and that's what they do, and they do a fabulous job at it. And we essentially, that's the service they provide internally to us as well as externally. And I look at what you're doing, kind of follow along those footsteps in a lot of ways.
Yeah, we have a couple examples where we've been brought into the design team where most of your clients on the mechanical electrical design side are architects, and very frequently they're going to have a separate envelope consultant to help them with the detailing or whatever specific concerns they have. And there's been a couple examples where people have shared, hey, SSR has an envelope specialty group as well, and we've been able to help those clients and develop relationships there where it's like, well, hey, that's a one-stop shop where I can get my team together for mechanical electrical, but then they can also be this resource for the exterior as well.
Yeah, that's a great story.
Mike, we're not talking about this group specifically here, but as a part of this project, energy modeling was performed. And I'll give a shout out to Clark Denson. Clark came to the team and said, hey, TVA has an incentive for $150,000 right now that if you do an energy model and you prove that you've met at the back end, you've met the requirements that they set forth as a part of that program, you get a $150,000 check. That was Clark brought that to the table, made all of us look good as an SSR ad, and ultimately the owner chose to do it, proceeded with it, paid us to actually help facilitate it. Yeah. And they just got their check last week. So it's kind of
nice.
It's a really kind of unique, and I tell people all the time, especially internal to SSR, these guys are the folks that make us look good as MEP consultants, because you can bring the expert to the table and say, hey, you kind of step back and just let them talk, and all of a sudden Clark talks, and it's just a knowledge base that we wouldn't ever be able to provide because of how detailed we would have to get at that one thing, and we have to be so broad sometimes that we don't have the bandwidth to be able to do that.
Yeah, and he's very focused on that group.
Very much so.
It's nice to have the expertise.
Absolutely.
And like yours, the same thing. It's an expertise. It's a unique expertise that just complements the other things that we're doing.
Very much.
So, really good stuff.
Yeah, and honestly, my previous firm didn't have the depth of mechanical electrical design that SSR has. So it's exciting for us too to be one of the smaller service lines, but to be on big teams with the depth of resources that you have, and then bundled up with all the 10 different service lines and everything that we can offer, and all the areas where we can solve problems is fun to be on, in projects like this and others that we would not necessarily be looking at if we didn't have such a diverse team. consultants.
It just excites me being in kind of the MEP world and project manager on this job to sit on an OSC call and see Mike Spock's notes and like the feedback that he had given from issues during his job observation reports, and and then see the owner light up about that. Like, hey, like we understand this. Mike said this about this, or the backing rods need to do this. I don't have a clue what they're talking about. But to know that there was an expert there that's part of SSR giving that feedback and sitting in that meeting, it's really rewarding to kind of see. And I told you that before, but some of the most positive feedback we got on this project was related to our other teams we brought into this other than just MEP. And I think it's because of the expertise that they bring to the table.
Yeah. When you think about Mike and you say he spent a couple days on the roof, I can see him now in the lounge chair with the umbrella. I'm sure his feet didn't stop moving the whole time he was up there.
I was going to say, if you know Mike, there's consultants out there who will do that to check the box, and that's not Mike Spock.
Not Mike.
He will be clear and honest with you, and that's why we love Mike and what he can do for a team. And this was a unique roof, right? I mean, this had this big barrel roof with metal on it and some flat roofs around it, and there were some challenges on tying those things together and a lot of different components. I don't want to go too deep into details, but there was
opportunities for problems.
Yeah, a lot of different things that Mike can bring his experience to and say, hey, this needs some adjustment, or let's rethink this, or let's put together a plan here, just from all that knowledge that he's bringing to the roof.
Yeah, absolutely. It's nice to have those experts.
That's right.
Very much so.
Well, we also performed some water testing as part of our commissioning work. So sometimes there's a separate testing agency that will perform some envelope tests. But for the right clients, we like to perform testing ourselves to make sure it's really the best way to do it, especially when we're contracted with the owner. That's truly third-party independent testing, rather than asking someone to kind of test their own systems, make sure there's no conflict there. But in addition to the consulting work, our guys, Chris Maurice and some others, were the ones running the water tests and hauling hoses and setting up a spray rack and a test chamber to pull the air pressure across the window. And it was helpful. We found some issues that you wouldn't have seen with your naked eye. Some gaskets in the or sealant joints in the storefront system that just got missed, and you really can't see with the finished product. But the test revealed that, right?
Yeah.
And that's why we run the test, not to say, hey, you made a mistake, but to say, hey, let's correct this now during construction, and not when the next big rain event comes through and causes leaks somewhere. So some people get down on failed water tests. You got a leak into the building, but it's always better than the alternative of not finding it. And it's a way for the team to honestly feel better that, hey, this system passed the test, it's working. Or in this case, there was a couple things that got missed, but then we could all meet up with the team and say, hey, looks like this thing got missed here, and we can go back and repair that at all the other locations if it's needed. So that's another thing that we can do, where we're the boots on the ground, just performing that testing. And we like to say we're consultants who can also perform testing. We're not necessarily a separate testing agency, but it's a valuable skill to have, to be able to knock that out ourselves and also be there on site to help diagnose it, right? There's some other testing agencies out there who might run the test and give you a report and walk away, but we're engaged with the team. We want to see it done right, so we're not just giving you a report. We're going to help diagnose it and figure out why did this not work, and testing lets us do that when it fails, and start pulling things apart and investigating, if you will. So yeah, I had a couple of those, but we're able to get them all buttoned up and squared away, and some confidence that those things are going to work.
That's awesome. Yeah, no, that's good. I mean, I think you're right. There's testing agents, and then there's consultants that are testing, that are really paying attention because there's a vested interest in it, in a way, right? You're not just not just being paid to do a test. You're being paid to make it work, and it's just part of the process. So it's good.
Yeah.
Good.
Yeah, and honestly, there's some concerns with some testing that's going on out there. When markets are booming for construction the way they are right now, so many things are going fast, and everybody's trying to check the box and move forward. And this is a way to make sure we know for sure we followed the ASTM procedure. Our guys have done this 100 times. We're invested, like you said, in the project, and we're going to figure it out regardless of schedule and budget. We're going to stay in those things and get it resolved. So there's some comfort knowing there that we've executed the test ourselves and done it the way that it needs to be done.
Yeah. Give the owner a little peace of mind for sure.
Right.
Yeah.
And I think this relationship off of this project has allowed me to get to know Greg better, where we've had other issues within my own team of other projects where architects didn't do an envelope the correct way, and we were being blamed mechanically for it to be a problem on our side of conditioning not right, or you're having stack effect, and brought you guys in, and they were able to figure that out, and connecting the dots is all it's about. But that kind of starting here and seeing what the opportunities that there are on a project, and being able to apply it to different projects when you get in kind of a bind that we don't really believe it's our problem to deal with out of the gate anyway. So
yeah, but as a whole, we want to solve the problem for the owner. We want to be there for them, and so if we can bring in other experts to help give a different view of it, sometimes it changes the conversation.
It does. Yeah. And it did. I mean, ultimately on that job you found that there were some issues with leaky windows very similar to this, that had we done a water test out of the gate, we could have potentially found some of those issues as well.
Yeah.
Talk a little bit about Greg. If you may not know, but they were having issues with backer rods. So we're precast panels on the exterior wall. And this is going to get a little technical for a second, but precast panels on the wall, and there were backer rods that the architect kept trying to figure out, and there was a lot of finds that you guys would see out in the field where they hadn't installed them correctly. And that was something that stood out to me, of like how detailed you guys were getting in the review of the envelope while you were in the field to make sure it was matching the details they had, or something that we had talked through, but it seemed like there wasn't enough of them to fill the gap, or there would be a potential for vapor to come through at some point. Like, can you talk a little bit about that?
Yeah, you're really going to test me on the detailed knowledge there. But yeah, I can talk about that for sure. So there was a lot of precast wall assemblies on the project, and when you're done with the project, you might just see the precast wall and the joint, but there's a lot of discussion on what's going on inside that little joint, and we talked about a lot of the different options that you can take for those joints. And one of those options being, how many sealant joints are you going to do? You're obviously going to have one on the outside, but is that going to be treated as kind of a rain screen, and the primary being behind that? So we talk a lot about primary and secondary means of moisture control. Is something the primary barrier, or is it a kind of secondary means to performance? So you can have one joint on the outside and have that be standalone, and there's a little bit of risk associated with that if there's any issue with that, then water can migrate around in it, get into the building. So one of the things we talked about as well was dual joints, which are very common, where you basically have two outside joints, and the first one's actually weeped, so it's stopping the bulk of the water, but some can get around it, and if it does, it can weep out at the one behind it. So we got into those discussions where that can be pretty beneficial to have that confidence that you have a secondary seal. Hey, one of these things fails, hey, we've got this other component there. But then there's also discussions on insulation in that gap, and what's the best material for that, and what's the value for it, and keeping that thermal barrier across the system. So yeah, we got into a lot of discussions there with the the orientation of the joints, the insulation, and then the backer rods themselves. So if you can imagine those two joints in there. If you do a dual joint, you've got to be careful on the sequencing that you put them in, because both of those products need to dry out. They need to cure out, and they need some atmospheric exposure to do that. And if you put them in at the same time, you risk kind of trapping one in there that really hasn't had a chance to cure out. So it's one of those things. Probably talk another 20 minutes, but it looks like just a wall with a stripe down the middle. But a lot of discussions on the nuances of how does that work, and do we have a coating on the precast? Is that going to stop here? And what's the primary? What's the risk going around it? How's it insulated?
Do these discussions happen during construction, or are they before construction?
A little both. So got the conversation going with the architect during design, and help get some things on paper, and then just kind of working through kind of typical issues in the field of material types, or some construction things are going to be a little different, right? Is that joint's maybe a little bigger than we expected or smaller, and how do we address that, and is that the actual right product that's supposed to be in there, and how's it installed? Is it twisted? Is it straight? Is it tight? So a little bit of both, and there were some challenges there, but we're able to help them work through those nuances of what we do.
And I think I might have scared Daniel Binkley through this, which is with Rufus Johnson Associates, being a local architect, not having done ice rinks before. Going back to the vapor drive that you talked about earlier, of how critical, we're doing precast, and this is a gap between the precast, and it has to be done right, so that we don't have infiltration into our building that ultimately brings moisture in. We're trying to maintain, a 5 to 10% RH in the space, and anywhere that we have a leak is going to be somewhere that's going to drive that moisture into our building. And so that's one of the reasons that this was kind of really a heightened thing on this project, is it's like we've got so much, 66% of the building is conditioned ice rink basically, and then you have a third of it that's normal typical basketball. So you really got to be careful with making sure that the exterior, but then even some of the interior spaces were evaluated properly, and then through site visits noticing that things weren't installed right. So Daniel would be like, hey, what's the deal here? Is this correct, or is there something we should be doing different? And that's where kind of the conversation started at, and really took off from there.
Yeah.
Right, we're both making visits, right? We're making quality assurance observations for the commissioning process, but David and his team were out there as well too, so they would snap some photos and send them over to Chris Maurice and Mike and other guys on our team and say, hey, what do you think of this? Does this look right, and how do we work through that? So.
Yeah, sounds like a great team.
Goes back to that true partnership.
Yeah. Good project.
Very good.
A lot of fun.
Yeah.
Long time in the making.
No doubt about that.
Yeah. Well, thanks for joining today. I think you guys did a great job. A lot of details, a lot of good stuff.
Great.
A lot of teamwork. Like to see it.
Appreciate it.
Yeah, sounds good. Thank you.
All right, that's a wrap. Thanks for joining us for this episode of SSR On Air. We hope you enjoyed it. Be sure to like and subscribe wherever you get your podcast. You can also connect with us on social media. Links to everything can be found in the show's notes. Take care, everyone. See you next time.